Here we go with factoring trinomials, but what makes these notes just so subtly different from the last is that you won't have a number that is only equal to 1 out front. So you'll have a equal to a bunch of different deals. Some people call them numbers, I call them deals apparently. And the important thing to note is that you have to have a trinomial in the form of ax squared plus bx plus c. So that when we look at number 1, we can figure out what a, b, and c are. So let's go ahead and rewrite number 1, where we're told to factor each trinomial. So if you need to pause to rewrite this, go ahead. But I got 2x squared plus 11x plus 12. And the whole deal here is I see a number like 2 out front. Now we normally like to simplify whenever possible. So the first thing you'd say, well, can I just simply pull a factor of 2 out? And you couldn't, because you'd have to be left with something like 11 halves here if you did. If you end up realizing more about this section, you realize that doing problems with an a out front is way more involved, and if simply factoring out a 2 means you don't have to do it, then that's a nice thing. So we're going to look for factors of not just c anymore. We're going to look at factors of a times c. Now a lot of times I don't like to write this out, I just kind of picture it. So you can write AC if you'd like, and I guess I should. So here's AC, but you have to do this at least in your head. 2 times 12 equals 24. Write it for your notes, but know that maybe you cut that corner later and don't bother showing all of this. And just like before, we're looking for the factors of 24 that add up to 11. Now this one's nice because those factors would be 3 and 8. So 3 plus 8 gives us 11, and 3 times 8 gives us 24. So again, just to be clear, this 2 and 11, this 2 and 12, that came from here. That's what produced the value of 24 that we wanted to target. So we were looking for the factors of 24 that added up to 11. If you look back at this work, that might not be 100% clear. So remember, you can rewatch these videos. Now I'm going to write 2x squared plus 3x plus 8x. And honestly, it does not matter if you wrote the 3 or the 8 first. If you're interested, try doing this problem both ways and see what happens. Now, like the old grouping problems, we now have not 3, but 2 terms and another 2 to give us 4. And earlier when you factored by grouping, you saw what was the greatest common factor you could pull from the left 2 terms, which in this case factors out an x to leave us with 2x plus 3. And then on the right side, we'd factor out a 2x, which leaves us with, I'm looking for the greatest common factor, which would pull out a 4, leaving us with 2x plus 3. So this means that we had x times 2x plus 3, and then we also had plus 4 times 2x plus 3. And since those are the same values of 2x plus 3, I can go ahead and parentheses x plus 4. So this is the factored form of this first problem. Now what will happen is, one of the common errors you will make is that you might pull out a greatest common factor that ends up being not big enough or might be incorrect. But the cool thing about these problems is if you end up with the same here as here, you probably are comfortable moving forward. If you don't, it most likely means you should restart the problem and go from there. Let's do another example. Rewrite 2. All right, we got 7x squared plus 29. The only factors of 7 are 1 and 7, and I can't just pull out 7 from all of this. So it looks like this is going to be one of those trinomial problems where a is 7, b is 29, and c is 4. AC would be 7 and 4. So if I multiply those two numbers, I get 28, and I'm looking for the factors of 28 that add up to 29. The only way this will work out is with 1 plus 28 to be 29. Like I was saying, if you start heading down the wrong path here, something's not going to work out in this step, And that means you have to go back and reframe the way you're thinking about it. So 7x squared, and I'm breaking 29x into 1x and 28x. These first ones don't have any minus symbols, and they're kind of keeping it that way so that it maybe feels a little bit more simple and straightforward. From the left two terms, I can factor out an x, which will leave me with 7x plus 1. On the right side, I can factor out a 7, which will leave me with, oh dang it, I did it again. I can factor out a 4, which will leave me with 7x plus 1. So that then my two agreeing parts on the left are x plus 4, and they both were being multiplied by 7x plus 1, and this is my totally factored out problem. Often it's nice to scan through and see if anything can be factored from either of the parts of the parentheses on the left, and the same deal over here. And when you look at it, you know you can't. Number 3 will end up being a little bit more involved, so let's check it out. And by a little bit more involved, I just mean we have to figure out what's going on with these minus values. So I have 10x squared minus 43x plus 28. Same deal as before. 10 times 28 gives me 280. And I'm thinking to myself, well, maybe it would be nice if I didn't have to think of that. Like maybe I could actually just pull out a 1, a 2, a 5, or a 10, which would all be the factors of 10. On purpose, I look here rather than the other numbers, because 10 might have the fewest number of options. Depending on how comfortable you are with prime numbers, maybe you looked at 43 and you're like, well, you know, that's a prime number, that's not happening. But I know that if I'm going to target 280, it's kind of a large number, and I have to have those factors add up to 43. I'm not thinking about 1 times 280. I'm not thinking about 2 times 140. I'm working my way inwards to get to there. And, you know, maybe I'm thinking, well, what would 3 times something be? That's a dead end. So maybe I try to divide 280 by 4. That gives me 70. But if I combine 70 and 4, that's no good. Maybe I try 5. And that didn't work. 6. But get a calculator out and check these, because I'm not boring you by making you watch me use a calculator this entire time. But what I end up settling on is that 280 divided by 7 gives me 40. So it didn't take me too long to get where I needed to be. So let's see, you know, well, what are the factors of 280? Well, then I do 40 plus 7. Oh, no matter how high I go, that's not going to reach 43. Let's try 40 minus 7. Well, that would be 33. So I guess I have to keep going. Let's try 8. So 280 divided by 8 would give us 35. And it looks like the factors of 280, well, 35 plus 8 works. So here they're both going to have to be negative. So here's negative 8 plus a negative 35. Depending on how you want to write it, would give you negative 43. Kind of ugly. But the only thing they're throwing at us is larger numbers. And with these larger numbers, there's just a little bit of minus signs going on too. So that maybe it increases the chances of mistake. From the left two terms, I can pull out a 5x, leaving me with 2x minus 7. And then from the right side, I can subtract 4, leaving me with 2x. Now, we have a positive 28, so that means the sign's going to change to 7. And then now I can put 5x minus 4 together, which leaves me with 2x minus 7 on the right. I scan through this whole problem. I make sure everything's good to go. I can't pull a 5 out from the left. I can't pull a 2 out from the right. So go ahead and finish these other problems on your own, and you can use Wolfram Alpha to type them in with the instructions of factor out front to make sure you got the correct solutions. So this has been factoring, and we'll check about prime numbers later. Okay, so what this means is that if you have a polynomial that is prime, you cannot factor it. So let's look at whether or not we'd say yes or no to this first one. You'd rewrite them as 2x squared plus 5x minus 2. And normally you'd be looking for the factors of -4 that would add up to 5. And these are where they get frustrating because they're like a incomplete problem. So I know that -4 and +1 would be a choice, but that does not add up to 5. We could also have tried -1 and 4, but that would not add up to 5 either. So this would be a dead end, and so this would be prime. And if you wanted to, you'd say, like, yes, it is prime. And you got other problems here, and be very aware of the fact that turtles, indeed, are cool. Now, because these are frustrating problems, I would definitely suggest doing these on Wolfram Alpha, because I don't know about you, but I hate loose ends. Factoring trinomials, where you got a little number out front, little buddy.